Hey everybody, I'm Corey Minton, Observability Strategist Director here at Splunk, and I'm excited to welcome you to the Splunk Deep Dive for the Logitech McLaren G-Challenge.
Let's take a look at our data-driven insight powered by Splunk.
That's right, Splunk is a technology partner for McLaren, but we're also a sponsor of McLaren's Shadow Esports team, and they are the hosts with Logitech of the Logitech McLaren G-Challenge. And Splunk was excited to partner with the team at Logitech and McLaren to bring data-driven insights to the Logitech McLaren G-Challenge earlier this year. And as we get excited about Splunk's .conf happening next week in Las Vegas and virtually, we thought we'd spend some time this week walking you through kind of a data deep dive behind the scenes on how the observability strategist team at Splunk brought insights to esports and sim racing like never before. Now, this was I'll call it a dream team production of the observability strategist, and I'm excited to welcome two of the gentlemen from our team, Kyle Prinz and Matt Moore, staff strategist for observability here at Splunk, who were a big part of making this happen. And I'll let them introduce themselves. Kyle, why don't you tell us a little bit about yourself, bud?
Yeah, hey, my name's Kyle Prinz, staff strategist at Splunk. Yep, and I've been here at Splunk for about a year and a half in the Splunk ecosystem for about 6 years. Pretty new to esports and sim racing before the start of this, but yeah, I've been doing this for a little while now and having a real fun time doing it, man.
He did really good in all the racing that we've done, although we did get the pants beaten off of us by the McLaren Shadow team pretty handily in everything we've done.
Confidence check there, yeah.
A little challenging, but also joining us is Matt Moore. Matt Moore, tell the folks a little bit about you.
Thanks, Corey. So I'm Matt Moore. I live in Melbourne, Australia. I'm in North Carolina at the moment, but I'm usually based there, living with my partner and a malodorous but beautiful and energetic mutt called Ruby. I'm an aspirational data scientist, and I'm absolutely loving the insights that we're getting from some of this esports data, which, while I can't drive a car to save my life, I can definitely look at the numbers and work out what's going on.
Which is actually kind of a funny story. We were actually all trying to get together in the same place this week. And Matt normally in Australia, but this time in North Carolina, but he doesn't have a driver's license. So he couldn't actually come join us. We couldn't find a place to meet, but that's okay. So don't mind me, I'm breaking things in my home. It was actually my Xbox controller falling off, which is very appropriate given the thing we're talking about. So Kyle, let's start with you. I want to kind of give folks a background on, why is it that Splunk is so interested in esports and sim racing, and kind of how maybe give folks a little bit of a kind of a recap on how we ended up here sponsoring the G Challenge and working on data-driven insights.
Yeah. This is a little bit of a start of how did we get involved with esports and how Kyle discovered what sim racing was. So in 2020, we started with what's called the virtual race to .conf 20. Splunk's .conf user conference that year was virtual, as was most things in the world. So we wanted to find a way to connect with people and have a race and have a good time while still doing it through the comfort and safety of our own home. Through that, we were able to build, I think we had about 10 races of a global racing series of racing events that were hosted before the week of .conf. But through that, we were actually able to then pull in all the data into it and actually show insights of the races themselves, kind of get an idea of what was going on with the cars, which was pretty cool because, in F1, they put sensors in the cars, and that's really awesome. But to be able to do that in esports can be a bit tricky. So we were excited for the challenge. However, we had one huge fail.
We did.
We showed exactly, the end result of what we did, but we didn't show. And that's where we decided 2021 we would take it a bit further with a formal program called Data Drivers. And Data Drivers was a monthly series over the course of, I think, 6 or 8 months, where we had 2 parts to this program. One was a race part where, hey, everybody jump on, race. We'll collect your data. We'll have some fun on the race. See who can be the fastest person on the track. But then also, no, it wasn't me either. It's it's frustrating, but that's all right. That's all right. We got to the hack part. That was the fun part. That was the fun part. And that's where we took the actual data that we created from that week's race, and then we ran it through Splunk and started to ask questions of it. So anything from like, hey, how is the GPU performing on each of the gamers' PCs, all the way down to, are the tires properly balanced, and is the tire wear happening synchronously across the board? So that was pretty exciting to have a part of that. And then from there, that led naturally into the Logitech McLaren G-Challenge, where McLaren and Logitech are both sponsors of, and Splunk was able to sponsor that as well. And we were able to show some of the data and insights that we got out of that on a professional and global scale as well, which was pretty exciting.
Yeah, it's pretty fun actually. If you get invited ever to the McLaren Technology Center over in Woking in the UK, and you go into their shadow studio where they actually have the sim studio and broadcast area. It's where their team trains for a number of the esports competitions. They actually have Splunk up and running. You'll see some observability cloud dashboards showing real-time metrics for each of the drivers, and then some competitive dashboards that are similar to what you'll see in this week's broadcasts talking about the G-Challenge. Now, speaking of data, Kyle, I want to spend just a quick minute with you on, anytime we approach a project, we had a vision in mind, which is we wanted to bring insights to esports and to the broadcast. So that's good.
Yep.
And we'll dig into those stories as part of the subsequent episodes. But one of the things you also have to do as a next step is think about data. So why don't you tell the folks a little bit about how we solved that getting data in challenge to go from thinking about less about, real-time real sensors in an actual car sending data to instrumenting a digital application.
It led to what I like to refer to as the digital plumber, or the plumber of the 21st century, where we want to build beautiful dashboards and visualizations and gain insights out of that. However, we have to start with the inception of the data itself. So how do we create that data, and what do we want that payload to look like? How often do we send the data? What do we want to collect of versus how often do we want to collect that data? We don't exactly need the weather every second, but we do need maybe RPMs multiple times a second. So through that, we were able to find a GitHub repository featuring an esports racer named Kudu. And Kudu and a few other contributors have built a Python interpreter for iRacing. And through that, we were able to collect over 400 data points detailing car, track, environmental, computer session, a slew of different things. And then we were able to sample those multiple times a second. Now, with Kudu giving that back to the community, we wanted to do the same and not follow the errors of our way in 2020. And we have a GitHub repository, and we'll drop a link in the show notes or the chat, and you'll be right over there. One of those ways.
I'll get it there in a second. Hang on.
Yeah, it'll be fine. But through that, we've actually open sourced the code, and it is super easy to be able to see how we're doing it. So if you want to maybe edit it, make a modification, find some insights off of that, maybe make it a bit better, please.
Go for it.
Contribute. Again, this is part of the community process that we want to do.
Yeah. And now I will say this is kind of, it's fun. A lot of what we had done up to this point was really around iRacing, right, as a platform, and iRacing, really impressive simulator. And if you've participated in any of the data drivers activities, that's kind of where we started. I will say though, as a preview, starting tomorrow, we've got our race2.conf for this year, where we're actually transitioning over to F1 2021, and we're excited about F1 2022 coming out in July. But yeah, so the iRacing, kind of a different animal, very different sort of telemetry output. So Kyle, tell them, I'm sorry to interrupt you. I wanted to make sure that the juxtaposition between iRacing and F1.
That's absolutely right. And what we're doing too is we're getting that into our product using our some of our native libraries via Python. So we were able to format that data correctly, get it into where we want, and be able to get visualizations back out of that. And if this is something that you're interested in, please join our Discord server, Data Drivers, and we have some more insights coming out of that over the coming weeks. But yeah, it was really exciting to be able to be the person to create the data, but that then also led to some challenges as well, Corey.
That's fantastic. Yeah, great segue. So Matt, one of the things that we always talk about, data is important, but it's really the story that we're trying to tell. And with these broadcasts, our outcome and the story, at least in my mind, was we wanted to make something interesting. So like in a racing context, broadcast, what was it in your mind? Because you were kind of the mastermind behind most of the visualizations, if not all of the visualizations we created for this thing. Well, kind of where did you start in the why and what you were trying to show for these observability use cases for esports?
Thank you, Corey. In my mind, a race is a complex system. There's a lot going on. You've got the human inputs from the drivers. You've got the cars as they change position and jostle for supremacy around the track. You've got the physics of it all. And we wanted to be able to ask questions of that. I mean, obviously, from a driver's perspective, they want to have short lap times and come first and win. From a broadcast perspective, we want to be able to identify where interesting things happen, which corners are dirtiest for accidents, where the overtakes occur, where pileups are. So we wanted to be able to ask those questions essentially with a data-driven approach and identify what good looks like and be able to take that back to both the drivers and the broadcast.
Yeah, it's fantastic. That's like by definition what observability really is, right? Is it's understanding what is happening in something that is mission critical, revenue generating, like super important, understanding how the component bits are performing and really trying to understand like what is it happening as it should. And if it's not, then taking action to remediate. And that was really what we're after, right? Is to bring light to some broadcasts and highlight those interesting activities. Now, data is critical, Matt, like as we talk about, but this wasn't like an easy instrumentation process because we have data being streamed, as Kyle said, from gaming PCs, around the world. There was 10 racers in each of the series. We had an open wheel that obviously drew a bit more of a broad audience, and then we had these stock car races, which is NASCAR here in America. But trying to build visualizations that matter to broadcasters with data that's being spit out from a wide variety of platforms has got to be kind of challenging. So Matt, in fairness, let's give the folks, like most of the folks probably watching, you're probably a bunch of engineers and geeks like us. So let's talk a little bit about the reality of what's happening, not just the pretty pictures of what we showed on the broadcast to get there.
So yeah, there are a couple of things. I just got to say, one of my favorite things about the original Splunk platform is when it would start up, it would give you a little message of the day. And my absolute favorite one was Splunk. See your world, maybe wish you hadn't. That's
good. That's a t-shirt quote for sure.
Absolutely. So this happened here when we got data in from these 40-odd esportsmen. The thing that jumped out immediately is they don't seem to care about NTP. They don't care about whether the clock on the machine is correct. We do, because we have to stitch the race together and work out what's going on. They absolutely didn't. It was all over the place.
So what are we seeing here? So help me understand how that manifests itself in the data.
Okay, so this is a before and after shot. On the left-hand side, we can see as a race occurs, the time at which each driver transitions from in the lobby to get in car to racing, etc. Gotcha. When a race starts, it should start for all of the drivers at the same time, or you'd think, right?
One would assume.
You would assume. What we found was because their clocks were all over the shop, we'd end up with the race apparently starting at different times for different drivers. In fact, no two drivers had the same clock stamp. Clock synchronization did not happen for these guys. Yeah. It was insane.
Which actually tells you a story, though. It's like the data we were getting was from the actual endpoint devices versus, the application engineers that have designed the game have obviously figured out a way to clock sync in real time the activity of racing. But we didn't get the benefit of that in our telemetry.
And for the analytics we did, we absolutely wanted, we need the timestamp to be critical. If we're looking at a point in time, we want to know where all of the drivers are so we can start comparing the location. Luckily, Splunk is a beautiful platform. Because we have those ticks that should be happening at the same time, we can recognize them and after the fact, bring those events together. So when we're looking at 5 minutes past the hour, it's 5 minutes past the hour for every car. And we can get that snapshot of the track and start doing our analytics there.
Brilliant. I love it. Now, let's go a little step further. Let's talk about the actual tracks themselves, because you've got some differences, again, in there's the NASCAR style tracks, more like ovals, or the kind of the super speedways, and then you've got these road racing tracks, which obviously have a ton of turns in them. Let's talk a little bit how we were dealing with some of that turn challenge of bringing insights there, because I felt like specifically in the road racing, the turn analysis was probably the most interesting piece.
No, you're absolutely right. So from the data itself, we got a lot of handy information. What we didn't get was whether a driver was approaching a turn or through a turn. We didn't get geo coordinates. We did get the lap distance, though, so we knew how far around the NASCAR track or the Hockenheim circuit, the Red Bull Ring they'd gone.
Yep.
So one of the things we did was augment that data. This was actually a fun process. So to be able to work out where the turns were, Corey, you were driving around the track slowly while we pulled the data in. So think 5 miles an hour, pressed up against the windshield.
That's how I generally drive anyway, but I don't want to talk about
Corey.
it.
And what
I was able to leave my Crocs on while I was driving, though.
There you go.
Yeah.
So what that allowed us to do is when we got to an interesting point in the track, so the brake zone or the 8-quarter apex, stop the car so we can see what the lap distance is, and then save that as a lookup. So when we drive around the track at top speed, we know whether we're approaching a corner or not, so we can start understanding ideal braking behavior and things like that.
Yeah.
The other thing we did, and this was, I'm not going to go into the details of it, but we're able to get geo coordinates by taking SVG maps of the tracks online and working out which lap distances corresponded with XY coordinates, which is what we're looking at here. So we're able to reconstruct the geo coordinates of the race and plot where the corners are occurring, which is very, very cool. And it's really nice to have a platform that allows us to fill in the gaps of the data as you're working with it.
Interesting. I love it. So let's get one more tidbit because we want to be respectful of some time. I want to look at one more kind of double click into this, track data a little bit. Was there anything just in kind of general that we don't want to give anything too much away on the broadcast that we're going to be getting to? Was there anything like really interesting that you found across all tracks? Oh, these are beautiful bubble charts.
Oh, I know. How gorgeous are they? So the answer is yes. We wanted to be able to get geospatial analysis of the tracks to understand driving stuff. But one of the things that came out very, very quickly is depending on the load of the machine or the render time or render complexity of the tracks, we noticed that frame rate actually varied depending on where you were. So we can see here we've got hotspots, high frame rate around the corners of NASCAR. I would have expected the opposite, but well. And the straights of the open wheel races. But when we look at the variation of the data, standard deviation, how much the data flickers around, how unreliable it is, we can see that very, very interestingly, there's points on the track where there's a lot of variations. So the machines are really, really working hard to be able to render the physics or the tracks or things like that, which I thought was interesting because it wasn't what we were looking for. But we've taken one complex system and we've worked out what's happening within the machines themselves from what you'd think would be completely separate data.
That actually is, again, another really powerful analog of the kind of the concepts of observability, right? It's understanding what's happening under the covers. Because again, our business outcome that we were trying to drive was race analytics. It's interesting turn analytics of what's happening on the track. But what we're learning is kind of some interesting things that are happening in the infrastructure that may actually have been affecting, the outcomes that the drivers themselves were trying to drive. So that's interesting. So I love that. So I will say, everybody stay tuned this week. We're going to have another broadcast Wednesday and Friday at the same time on our Twitch channel to actually go deeper into exactly what we built for the stock car racing and for open wheel that we're going to get a lot deeper. But one thing I want to talk about before we wrap is I want to talk to Kyle a little bit about one cool thing that kind of happens under the covers that maybe you don't fully think about when you think about trying to not only build analytics for a broadcast, but then how do you actually take that and make it be useful longer term? And so one of the things that we've got going on next week during .conf on Monday is actually our Boss of Ops and Observability. And Kyle, we've actually made available an episode using the data from this G-Challenge that folks are going to get to use. But in order to make the race like not just be a static data set that happened back in January, tell the folks a little bit about how you actually make this data manifest as if it's real and like we're seeing right here, like there's actually drivers, on track.
Yeah. So we, it would be cost prohibitive to have 10 racers from around the world racing constantly.
I mean, I'm
So-
sure somebody'd love to be paid to do that.
Yeah, there would just be no bathroom breaks, and your races would have to be 100% the same. So
Easy enough. No problem,
yeah,
right?
no problem. Consistency through and through, sleep deprivation, no problem. Yeah, they'll
And
be
this
fine.
is where tech comes to the rescue.
Yes, exactly. So what we were able to do was take the data that was already ingested into the Splunk platform and created during that week, or excuse me, yeah, that weekend. And we were able to export that, and we put it in a few different formats, and we realized quickly that CSV is a bit nicer on storage than a JSON payload. And you wouldn't think, comma versus brackets would make that big of a deal, but given that we're sampling 10 racers multiple times a second over hundreds of data points, it got to be a pretty big file. So we actually exported the data via CSV. We then built a Python script that will parse through that data and send it in. The first hurdle that we had to get through was obviously, if we're just going to take the data point and send it back into Splunk, it's going to have the same timestamp.
Yeah.
So we had to work through a hurdle of how do we keep the data relative to each other, but also make it generate in what looks like real time. So that was a pretty neat sub function that we built. I believe Matt put the finishing touches on it, which Matt
Pretty
is
common around here.
Yeah, he's Doogie Howser. He's boy genius, and it's absolutely wonderful to have him on the team. But yeah, we were able to solve that problem, start to get that data ingested, and then it just runs through. Well, we had that as a Python script, but as you know, with Python libraries, it can be a bit tricky to make that modular and move around. So we put that into a Docker container and then spun it up into our Kubernetes cluster that we have for data generation. And what's really wild is we're able just to feed it a CSV. So depending on what race it is, we feed it that CSV. We feed it a HEC token and a Splunk Enterprise IP, and we're good to go. And so these data generators have been running for months now. And what they're able to do then is give a 100% consistent, 100% uptime data generation experience. So people like Matt, who love data science and getting into that, now have the capabilities to run insights against it at any time of day and have an expected outcome. So all of that lives on Docker Hub as well. And if you're ever interested in hearing more about that, please hit us up on Discord or Slack or Twitter, and we're happy to talk through it some more.
Or even better, if you're joining us at .conf next week, come by and hang out with us. If you haven't registered, conf.splunk.com, use the QR code, use the link that I'm dropping in the chat now. But make sure you come to .conf. And as Kyle was talking about, this episode, this thing we're talking about, if you want to get hands-on with the data, that's part of our Boss of Ops and Observability challenge. It's also happening next Monday, so a week from today, at .conf at 6 p.m. Pacific time. And you can sign up for that, sign up to join us for that event. And it'll give you an opportunity to get hands-on with Splunk in a variety of kind of normal observability and IT ops use cases, but also some fun ones like this that actually allow you to play with data that's clearly not related to observability in an IT and modern app deployment concept, but the analogs are there, and it's esports and it's fun, but the things that you would learn would be totally applicable to your job in IT operations, observability, DevOps, SRE work. So we definitely want you to come hang out with us. Got some great things happening to .conf. In leading up to .conf, we also have our race to .conf starting tomorrow at 8 a.m. Pacific time, and another race on Thursday at 5 p.m. Pacific time. And this one you can sign up for those races in the link in the chat. And basically what this is if you've got F1 2021 running on a PC and you sign up, you can join us for a race. And if you are one of the top 2 finishers in each of the races tomorrow and on Thursday, then you get to join us for a race virtually on Wednesday, where you'll get to race against the fastest drivers at .conf, because we've got 8 simulators at .conf next week where you're going to get a chance to come racing with us and see some of these demos and things hands-on and in real life, but also some of McLaren Shadow's talent. We've got some of the most popular streamers in the F1 world joining us at .conf to give some coaching and also to give everybody a little bit of a challenge in racing at some of the best racers on the planet. So we definitely want you to join us there. So come to .conf, be sure to sign up for Boss of Ops and Observability, and make sure that you come check out all the amazing McLaren experiences that we've got going for you at .conf. Matt, Kyle, did I miss anything? Did we cover all the things we want to cover here in episode 1 of the deep dive?
Yeah, I think we're good to go, man. I'm pretty excited for the coming weeks, and yeah, let's have a good
That's
time.
right. So Kyle, Matt, and I will be back tomorrow. We'll be in person together finally, which will be great. And we will actually be broadcasting and commentating the race that you're going to get to enjoy, the virtual race to .conf for 2022. Well, as we say with any of these broadcasts, whatever you're into, be data driven and join Splunk's data drivers. We'll see you all at Conf.